In a previous video, I was showing how to multiply any number by 11, and during the proof, I used a technique whereby I deconstructed the number into components which represented the place value that each digit resided in. This technique is a very useful and commonly used technique for some algebra word problems that involve conditions for the individual digits of the number. One such problem is the digit reversal word problem, where you are somehow told that the value of a number would change if you moved some of the digits around. So I made up a new problem to help demonstrate this technique. So the very first step in solving any kind of word problem is to read it at least twice. It isn't reasonable to think that you would read it once and gain everything you need to know about this problem. I'm thinking of a two-digit number. The two digits have a sum of 8. If I reverse the digits of the number, I get a new number that is 10 less than twice the square of the units digit of the original number. What is the original number? So after you read the question a few times, your goal is to take the English sentences that were presented to you and convert them into algebra so that we can do the appropriate manipulations. First, it says I am thinking of a two-digit number. Two-digit numbers have a tens place and a units place. So I can write the original number. Its form looks like TU. Now that's not T times U, it's a T next to a U. But the actual value of that number is 10 times whatever's in the tens place plus 1 times whatever's in the units place. That is how we represent the value of the original number that is being discussed. It then says that the two digits have a sum of 8. The two digits are T and U, so that tells us that T plus U equals 8. The next sentence says if I reverse the digits of the number, I get a new number. So the new number, its form looks like UT because the digits were reversed. But that's not its value. The value of the new number, we're going to take the same expression that we have 10t plus 1u and reverse it. That means that u is going to be in the tens digit. So 10 is going to get multiplied by u, and then 1 is going to get multiplied by t. Now we can write a skeleton for the third sentence to try to help it make sense. It says that the new number that you get is, so equals, 10 less than, so I have to subtract 10 from something, 10 less than twice the square of the units digit. So the units, I'm just going to write the whole word here, units digit, and they said the square of the units digit. And it's the units digit of the original. I just wrote OG for original. Now filling in some of what we know, the value of the new number is 10u plus t, that's from right here, and it equals 2. Now the original unit's value is what we called u in this definition right here. This is 2u squared minus 10. Now the next issue that we have is that this equation has two variables. It has a u and a t. But thankfully, we were told that t plus u is 8. And since the equation in blue has u in two different places and t in only one, it could be helpful to isolate t in this top equation and rewrite that t is 8 minus u, and then use that to replace the value of t right here. 10u plus 8 minus u equals 2u squared minus 10. Combining like terms, we have 9u plus 8 equals 2u squared minus 10. And now rearranging the terms in this equation so that one side equals 0, we get 0 equals 2u squared minus 9u minus 18. You have the freedom to choose whichever technique you'd like for solving this quadratic equation, but this one factors nicely. And it factors into 2u plus 3 times u minus 6. Now, if you have trouble factoring, you can refer to a different video to help you with that technique. But for now, we'll assume that you have that skill. Now, using the zero product property, which says that when you have the product of two numbers equaling 0, that one of those numbers must equal 0, it tells us that either 2u plus 3 equals 0 or u minus 6 equals 0. Solving for u on the left equation, we get that u equals negative 3 halves, and on the right equation, we get that u equals 6. Now, if you remember what u represents, u is the units digit of the original number that we're looking for. Negative 3 halves is not a reasonable answer for that context. If u is supposed to be the units digit of a number, negative 3 halves is not an integer, so this answer is not reasonable. We're going to reject it. The only reasonable answer is u equals 6. And that u is the singles digit. Now we have to make sure that we actually answer the question. The question is asking, what is the original number? U is only the units digit of the number, so we need to find the tens place as well. Thankfully, we had this equation that told us that t is 8 minus u, and we know u, so t is 8 minus 6, and so t is 2. T was the original number's tens digit, and u was the original number's units digit. So our original number is 26. Let's see if our answer 26 makes sense. We'll go through the prompt one sentence at a time and make sure that it actually works. So I am thinking of a 2-digit number. 26 is a 2-digit number. Good. The 2 digits have a sum of 8. 2 plus 6 is 8. So that's good. The next sentence, we might have to write some stuff down. If I reverse the digits of the number, I get a new number. And that number is 62 because we reverse the digits of 26 and get 62. I get a new number that is 10 less than, so I'm going to subtract 10 from something, twice the square of the units digit. So twice the square of the units digit that we found was 6. So let's see if this actually works out. 6 squared is 36 times 2, and we'll subtract 10. 2 times 36 is 72, and minus 10 does indeed come out to be 62. So this right here is just a sanity check to make sure that what you got for your answer actually is a good answer. So we have found that our original number is 26. I hope this helps. Thank you for watching. I hope you enjoyed this video. See you next time.